Hello, we're going to do an example of solving a beam using structural engineering software. We're going to be using visual analysis to solve this problem that you are seeing on your screen. Um, it's um, it's a it's a beam that has two members connected. As you can see on the beam, by the problem statement, we're going to have a roller at A. We're going to have a pin connection at B. We're going to have a roller at C, and this is considered a pin support. And we're going to have all these loads that you're seeing. And now here we have the solution. So we're going to do this problem using visual analysis. And you're going to see that we're going to get the same results that you get if you do this problem using statics. So we open the visual analysis software. My software might look a little different from yours because I have a professional version and you probably have the educational version, so it might look a little different. So the first thing you want to do is here, you're going to have a left menu here, and in modify, you're going to do, and here, a structural type, you want to do a plane frame because we're going to be doing a 2D problem. So that's we're gonna work on a plane, on the two-dimensional plane. After that, we're gonna start drawing members. Here you have different tabs. Home is the one we're gonna be using most, but if you press here structure, you wanna make sure that this draw members is pressed on, okay? Because if you don't wanna draw anything, if you're trying to draw something and nothing is coming up, it's because maybe draw nothing is pressed on. So make sure that draw member is pressed, and then go back to home, and then we're gonna draw like a line. Okay, uh, I'm gonna do well. Let's draw three lines, one after the other. Where you ended one, then you start the other one and the other one. I'm gonna do this because the problem we are doing has three segments. Okay, so I have that line. So I want you to see that if you, for example, if you press a node, then on here on the left side, you're gonna get the information of that node. For example, this is node 1, and these are the coordinates 0x, and then y will be 12. And then you can see if you press the different nodes, this information will change. Likewise, if you press the members, you will get information. For example, all my members right now, they're saying I'm using W14 by 22. This is all right because the type of program we're doing really doesn't matter what kind of member I'm using. But if you have a different one, it doesn't matter what kind of member you have because we're still gonna get the same results. The results that we're gonna look for don't depend on the shape of the beam. Okay. So if I go back to the problem, I'm gonna see that I have to have a segment of 10 feet, then another segment of 10 feet, 6 plus 4, 10, and then another segment of 12 feet. Okay, so 10, 10, and 12. So if I go back to visual analysis, then this one is at x equals 0. So then this one has to be at 10 feet. So luckily, I draw that one at 10 feet, but if not, I would just change it here. Then this one, if I add 10 feet more, it's supposed to be x equal 20. That one is 26, so I'm going to fix that. I'm going to do 20. And then the last one, if I add 12 feet, it's supposed to be 32. Looks, it's at 40 feet. So I'm gonna change that to 32 feet, and now I have my bin. Um, so I have my bin. Another thing I want to show you while we're here is like if you're clicking something, then you're gonna get the information here what you have, like on the node or the member. If you're not clicking, let's say not anything, if you click out the I don't know the background, I guess, then uh, you're gonna get other information. But then here you can go model filter here, and then you can change what you look. For example, let's say for my members, I want to look at the shape. You see, now I can see what my shape is. And for the nodes, let's say I want to look the location, maybe the name, let's say, and you can see the names they have. I'm gonna turn that off. I'm just gonna leave the shape out there. Well, I don't even need the shape. Maybe for the members I can do, but there's all sort of information that you can look. Let's say the length. I want to see. You can see I have 10 feet, 10 feet, and 12 feet. Okay. So I'm gonna turn off all that. Another thing I want to show you now is here on this menu. This is a very useful button, zoom all. If you press that, it will like zoom in on all your structure. You can zoom in or zoom out, right? And it doesn't matter. You can always go back and zoom on. Also here on this square, on this cube on the left corner, if you can see your structure on 3D, you can start changing your views, and you can always easily go back to the front and just see it and zoom out. And you can do also picture view. If you press this button, picture view, you can kind of like see what you're drawing, like not a schematic of the beam, but okay. You can always go back. You can also use on your keyboard the shift plus the arrows, and that will help you move your beam around. Shift plus the arrows up or down move. But you can do control and the arrows, and you can rotate it, okay, and you can like kind of like see your structure from different ways. Again, whenever that happens, or if you want to go back, you can always just press your front and then zoom on, and you have your structure. Okay, I'm gonna turn off the picture view and just look at the schematic of my beam. And now, so now continuing with the example, uh, going back to the example, remember I have a roller here, a pin connection, a roller, and a pin support. Okay, it looks like a fixed support, but the way it is connected is a pin. Okay, and that's what the problem statement says. Okay, so I want to do a roller here, so I press this one, and I know that a roller only has the way it's oriented in the problem. It only has a vertical reaction, so this means it's gonna restrict the displacement in the vertical direction. That's what D is for displacement, and Y is that is in the vertical direction. So I mark this, and it's fixed, and you can see now I have a reaction there. Here is a pin connection. That's not a pin support. Do not confuse a pin support with a pin connection. So I'm not gonna put a support here. I'm gonna go back to that one. I'm gonna do a roller here too. Okay, and then here is a pin support. So I'm gonna restrict X and Y, right? If this were a fixed support, then I will restrict also the rotation. That's what RZ means. RZ means the rotation around the Z axis. Okay, so that will be like, but I'm gonna keep that up because it's a pin support. Okay, so now what we're doing here is like I need a pin connection here. The way visual analysis works is if I click on this element, you're gonna see it's rigid connect. It means both connections, depending on what I do, if I connect it to another member, it will be rigidly connected and rigidly connected here. And then this member is also rigid connect, and this member is also rigid connect, means that all the connections between members are rigid. So what I can do is I click on this member and I do rigid simple. I do rigid simple because I want the hinge or the pin connection here on this side. I don't want it on this side. Okay, and that's enough. That will work. I could do that. I'm gonna do undo, but because another option will be to this member do simple rigid. And again, it's because I dropped the member from left to right, then I know that the first side, the left side is gonna come first. That's why I want it simple and then rigid on the other side, and that will work. What I cannot do, what will be a mistake, will be to do both members like do rigid simple, and it's like putting two hinges and then the structure will collapse together. You only need to put one hinge, only one hinge. So I'm gonna do undo. Okay, so any of those two solutions, only one of the members, you need to change one of the sides to simple. one of the ends simple. So I'm gonna do this one rigid simple, okay? And that will work. So now I have my structure, and with all the supports and the hinge and or the internal pin or the pin connection, just say. And then now what we're gonna do is do the load. Let's apply the load. So if we look at the problem, we have first a moment, a clockwise moment of 60 kips per feet. So for that, I just click on the hinge, and then I do a right click, and I do apply nodal load. And here I'm gonna put because all the loads are together in one case. I'm gonna put all the loads as dead loads. The problem doesn't specify if they're dead loads, live load, or whatever. I'm just gonna ignore that, and I'm just gonna do the everything. I'm gonna put it as a dead load together. Okay. Uh, as you saw in other courses, you will see steel structures design or concrete structure design. You can have different types of load that then you can add up together, so you can put the dead load separate and the live load separate. But I'm gonna assume all these loads are dead loads and put them all together. Okay. So it's here in the type of load I gotta change to a moment, and then it was 60 60 kips per feet. I'm gonna do okay. But as you can see, the moment is on a different direction from the one I wanted. I wanted clockwise, and it's counterclockwise. So I could click on the load and then delete it, or I could click on the load. As you can see here on the left side, I could just put a negative and press enter, and that will correct the direction, and now I have the direction that I want. After that, let's see, on the first segment, I wanted 2 kips per feet, 2 kips per feet distributed loading, uniform distributed loading. So I'm gonna now, because it's gonna be distributed on the member, I'm gonna click on the member, gonna do right click, and then on this menu that opens, I'm gonna do apply member load. Okay. It's a uniform load that I want. It's a vertical force. I'm going to change that to force Y. I want it downward, so I'm going to leave it negative here, but then I'm going to write 2. And I leave this on because it's going to be on the full span. I press OK. And I have the load. After that, I have a, a, a load of 5 kips at 6 feet from the left side. So let's see how I do that. I go and click on the member. I right click, apply member loads. Now it's not going to be a uniform load. It's going to be a single point. It's going to be applied at a single point. It's going to be -5. Negative is to indicate that it's downward. And the offset is telling me that it's going to be 5 feet. I don't want it 5 feet because I want it 6 feet from the left side. Because I draw the element from left to right, then I can just click here and change this to 6, and it should be on the right spot. Okay. Going back to the problem I'm trying to solve, I need a triangular load, 3 feet. So the problem, you cannot do this triangular load like that. You have to do 2 triangular loads. Okay. So you will see, I do click the element or the member, right click, apply member load. Then I'm gonna change this to linear. It's gonna be a linear load, force Y. Okay, it's gonna start at 0, and then it's gonna up to -3. Again, the negative is just the direction, and the magnitude is 3. And then it says, is it on the full span? No, it's not on the full span. It's just half the span. So it's gonna be from 0 to 6. Okay. And then I do click again, and I do another load, apply member load. Again linear, but now it's gonna be from -3 to 0, and then it's gonna be from 6 to 12, and I do OK. And now I have all my loads. Okay. Now, very important. If this was a real problem, then you will also want the self weight of the beans, right? If this were a design problem or something, but this problem we don't it doesn't give you the weight of the beans. It basically is telling you to ignore the weight of the bean, the self weight of the bean. But the program will automatically consider the self weight of the bean, and that will change the results. So we need to tell the program not to consider self weight. The way we do that is we go to load case manager, and then on here on service cases, okay, on the dead load, you double click this, and then here soft weight, you're gonna tell it no soft weight. Okay, do not consider the soft weight, no soft weight. You do OK. Okay, and then on load combinations, it will depend on I'm not sure if the student version have this or not, but this will be what sort of load combinations do you want. You know, the load combinations that you use for design, and you discussed it on structural analysis 1 on the previous course. So for now, I'm just gonna turn off the the code. I'm gonna tell them not to consider any code, so do not do any load combination. So that way, the only thing that I have is gonna be the dead load, which it doesn't matter if it's really dead load or not for the program I'm doing. I'm just considering them as if they were all dead loads. I'm gonna do close, and then I think we're ready. And then you can go here to this tab here to do the result view. Now, result view, what you're gonna see is an exaggerated um, deflection of the beam. It doesn't mean that necessarily the beam will deflect like that. And then you can kind of like change some things. You can like put the nodal reactions here. Okay. And then you can see I have a reactions here of 4 kips, then a reaction here of 45 kips, and a reaction here of 6 kips downward. And you can see that there are this exactly the same 4 kips, 45 kips, and 6 kips here. You get exactly the same reactions. Okay. If you have different load combinations or different loads here in this result case here, you will change to look at the other cases. But because we put all the loads in the loads, I'm only gonna see this case now. Okay. So as you can see, I got exactly the same reactions. Now, design view. I turn off the code at the load combination. So right now the program is confused and it's giving me this mistake. If I were to do, if I go back and I do load case manager and I tell it to do like, I don't know, this code ASC 716, do these load combinations and do close, then it will change. And according to that code, this beam will fail. That's why you get the red one here. This segment will work, but then this segment will. So this is not for this course because this is an analysis code, but for future course, you can use this to design. So you can start changing the member until you find a member that works. Okay. But this is for other courses. Now, if I go back here and I click on this member, on the first member, and I do the member graph, I'm gonna do, this is the sketch that is showing you the deflection of the beam. And this one shows you the shear diagram and the moment diagram. Okay. But I want to look at the whole beam, So what I can do is I can pressing with your finger the shift key and then touching one of the members, that selects all the members. Okay. And then I go to member graph, and now I'm gonna see the graph. And if you start comparing it with these graphs, You can see this one go from 4 to negative 16, then constant to negative 21, then it jumps to 24 and 6. If you go back, you see exactly the same thing. Okay, same thing with the moment diagram. Okay, 60, 64, 96, 100, 80. Okay, uh, exactly the same thing. The maximum, sorry, 64, the 180, everything is there. Okay, so this is just the beginning for visual analysis. Once you start using it to solving problems, you're gonna start learning a lot more. Okay, but this should help you to start with the program.